Okay, welcome to level 4 in the angles and polygons lesson. What we get is construct a regular hexagon with 1-inch sides. The only way that this is different from what we've done before is that it doesn't tell us what the interior angles of a regular hexagon should be. But if you think about it, it's got 6 sides. And we know that the exteriors have to add up to 360. So 360 divided by 6 equals 60. That means the exterior angles will all be 60, so we already know that. And if you think about it, the exterior angles and the interior angles have to always add up to 180, so the interiors have to be 120. So we've got that. So what we really need to do is do 1-inch sides and 120-degree angles. If we do that correctly, we should have a good regular hexagon. So I'm going to make a 1-inch side, and then I'm going to use my protractor and make a 120-degree angle. Pretty straightforward. Here's the 120 right there. I get my direction from my protractor. And I line it up. There's my 1-inch side. Here comes my next 120-degree angle. Line it up. One-inch side. Oh, too long. Sorry, it should have ended right there. 1-inch side. From there, 120-degree angle to right there. Basically, the construction is very simple. It's just like a level 3 from the previous. So I'm not going to bother going through the entire worksheet. Basically, it's highly repetitive. The only thing you've got to understand with this is how to calculate the interior and exterior angles based on the name of the polygon. And that's not too hard. Once you have your process down, it's really pretty easy. So there's our hexagon. Of course, we want to label. Remember, interior angles are all going to be 120. All sides were 1 inch. Okay, we're done. So let's look at the next one. Construct a regular octagon. Okay, we know that an octagon has 8 sides. The easiest way to figure out all the angles is to again go that exteriors, always think about the exteriors. The exteriors always add up to 360 no matter how many sides. So how many times does 8 fit into 360? Well, 8 goes into 36 4 times, that makes 32. 36 minus 32 is 4, carry down the 0, 40. 8 goes into 45 times, therefore each exterior angle is 45 degrees. And of course, they have to make a straight line, in other words, be a linear pair with the interior angle. So if this one's 45, this one's 135. Therefore, we have our angles. You measure 135-degree angles, 1-inch sides, you'll make an octagon, believe it or not. Okay, next, decagon. A decagon has 10 sides, like a decade, right? So 10 sides, that means, again, the exteriors, because in all polygons, the exteriors always add up to 360. If you want to know 10 sides, well, then the exteriors are each going to be 36 degrees. Piece of cake. And if the exteriors are all 36, then the interiors over here have to be 144. So you measure 144-degree angles, 2 centimeter sides, and believe it or not, you will have a decagon really quickly. Last, construct a regular 12gon. Okay, 12gon, first of all, that's kind of funny. Sometimes you would call it a dodecagon, but for simplicity's sake, anything with more than 10 sides, we'll just use the number followed by the letters G-O-N. So a 12-sided figure is a 12gon, therefore obviously it has 12 sides. 12 goes into the number 360, again, the sum of the exterior angles. It goes in exactly 30 times. So the exterior angles in a regular 12gon are all 30 degrees. And very simply, those have to be linear pairs with the interior angles, so the interior angles have to be 150 degrees. So if you want to make a regular 12gon, You alternate 150-degree angles with, in this case, 1 centimeter sides, and you will have a 12gon or a dodecagon. That's all there is to it. So, level 4 this week, pretty easy. Make sure that you got the idea. Here's the simple idea. Calculate the exterior angle, use that to calculate the interior angle, then construct. Piece of cake. Thanks. Bye.